Hello everyone. So in this project, we aim to demonstrate autoscaling of resources using Openstack. So our system consists of basically two virtual machines. As you can see on the screen, there's DevStack 1 and there's VM1. So DevStack 1 is the virtual machine in which you set up OpenStack. We'll actually first begin with VM1. So here I'm logging into VM1. uh, we are in a virtual machine VM1 right now, and in this virtual machine, we have basically cloned OpenStack's default dashboard, that's Horizon, and we have made certain modifications to that. So right now, I am basically running. So this has been done using Django's development server. I'm right now running the server, and I'll show you the dashboard, which is running on port 9000 here. This is basically linked to our OpenStack DevStack, which is set up on DevStack 1. So from our virtual machine VM1, we'll try to SSH into our DevStack environment. That's basically 1.8 here. So while setting up DevStack, we also had to install Heat components like Heat, Ceilometer, and AODH. And to install that, we had to make changes to a local.conf file. Here's the file, and as you can see, I'm basically highlighting that portion which I had to add to local.conf in order to set up these additional components. So we'll first have a look at our resources.yaml file, which is used to define the resources, which will be auto scaled. As you can see, there are two resources here. One is Nova Server, and the other is Nova Sender. The other is Sender Volume. Now we'll have a look at auto scaling resources file. So this is basically used to define the rules for auto scaling. Once this file opens up, we'll just discuss that. Also, as you can see, we first define the auto scaling group, and then we define the scale up and scale down policy. So the adjustment type, basically, in case of a scale up policy, is change in capacity, and scaling adjustment is one way. So this means that if an alarm is triggered, we scale the resources by a number one. Similarly, in case of a scale down policy, we scale it down by one, which is mentioned in the adjustment scaling adjustment parameter. Now here we see we have two alarms. One is CPU high and the other is CPU low alarm. So both these alarms use meter name called CPU util, and the statistic which we track, the meter tracks, is average. So this statistic is basically evaluated for a period of 60 seconds, and it is evaluated once. And if the threshold increases by 50, in that case, our scale up policy is triggered. In case of a CPU alarm low, scale down policy is triggered. So in this step, we'll try to create a stack using heat stack create command, and we use the YAML files we just showed you a while back. So you can see that this command is running, and uh, the stack which we just started right now is basically the create is in progress. So as we can see in our local dashboard, that this stack which we just instantiated, it has been created right now. And now if we go to our compute and instances, we can see that two instances which were created by the stack would have been created. Let's have a look. So yes, there are two instances which have been created, and floating IPs have been assigned to the instances. So we'll try to SSH into the instance which we just created using the stack command. As you can see, in order to SSH, we cannot SSH directly. We'll use the routers which are basically associated with our DevStack instance. So as you can see at the end, so what we're doing is we're first connecting with the router, and then we are basically trying to SSH into a system. using the private key. As you can see here, we successfully SSHed into the instance which we created a while back. So now we'll try to demonstrate how auto scaling is being achieved in our system. So for that, first we'll try to increase the CPU load using dd command. So as defined in our auto scaling YAML file, if the CPU utilization goes beyond 50%, there'll be a new instance which will be spawned. So just let's have so we use the dd command to increase the CPU load. So let's just have a look at what is the current CPU usage using top command. So you can see right here it's 50%. So we saw a while back how our CPU utilization had exceeded 50%. So when that happens, auto scaling policy is triggered, and as you can see, which I highlighted here, that a new instance has been created. So basically, we are able to achieve auto scaling through our system. So our project is able to address the five essential characteristics of cloud system. So the first one is on-demand self-service. So in our case, we're able to provision resources such as the server. We just saw right now how, and while provisioning the server, there's no human intervention involved. So the second point is broad network access. So as we saw in VM1, a user once authenticated can log into the dashboard, and he can actually create new instances using the dashboard itself. So the third point is resource pooling. So as we just saw that there were a new instance was created. That instance is basically created from a pool of resources. So the fourth point that is being addressed is rapid elasticity. So to the user, it actually appears that there's no set limit on the number of resources, and as and when he uses, so if his usage goes up, new instances will be spawned and it will be assigned to him. So the fifth and final point is measured service. So how this is being addressed is it's being addressed using Ceilometer, which tracks the CPU utilization and spawns new instances. And the number of new instances can actually be used as a parameter for creating a measured service. So that's it. We are done with a demo for our project. Thank you.